section 5.3, we're going to be talking about linear function patterns. This sounds a whole lot worse than what it is. Just know this is all a linear function is. It's a function whose graph is a non-vertical line, and it can be written in the form of y equals mx plus b. Hey, that looks familiar. Yes, it ought to, because we spent a chapter just on what this is called slope-intercept form. So some examples of what a linear function might look like. So we have a graph, and we have basically our ordered pairs are put in a line. So we got dot, 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 dot. Notice how it makes a perfectly straight line. This would be labeled as a linear function. Another type of linear function would literally be a line. All right, that is a linear function. And here's the other thing. We can also do a linear function that looks like this. Okay, or we could do a linear function that looks like this, or anything in between. Now, the one definition that it says this: it is a non-vertical line. So if I were to have a graph, this is my x, this is my y, and I had a vertical line like this, or a vertical line that looked like this would not be a linear function because of our rules of what a function is. A function, if you recall back from our previous section, it means that there will be no repeating x's. All right, and I paraphrase that. Notice that if I were to plot each of these ordered pairs and name them, they would all have the same x variable. And if I were to do the same thing, all the answers that are on this line have the same x variable. So this is, even though it makes a straight line, they are not linear functions because they are not a function. All right, so that's kind of the main gist of things. Now, what we have here is very straightforward and very simple. This should be pretty much a review because it's the same thing we did probably, I believe, back in chapter, I think it was chapter 4, I believe we were. 2 or 4, I can't remember what chapter it was in, doesn't matter. But anyway, it says use the graph or the table to write a linear function that relates y to x. It's asking you to write an equation that's y equals mx plus b. That is all that's happening here. So let's just look at it right now. I have a series, it is a linear function because we've been told. So really all we have to know is a couple things. One, we need to find our slope, and two, we need to know our y-intercept. Well, the second one's really easy. Our y-intercept happens to be right here. It crosses at the 0 on the origin point. So y-intercept is 0. But now we need to find our slope. Well, we can do it one or two ways. We can actually find our point, or we can just simply count. So notice how this is going by 2. So I can go, it's got a rise of 1, 2, 3. So I have a rise of 3, and it goes over by 1. So I have a slope of 3 over 1. Now that I know that, I can simplify that just 3, and then plug everything back into this equation. So y is equal to, my slope is 3, x plus 0, so y is equal to 3x. I'm done. Pretty straightforward. Same thing with here. Right now, we can look at our y-intercept, very easy to be 2. That's easy. And notice that this is a horizontal line that we've created here. So it has a slope of 0. Knowing that, we plug everything in. Well, we could say 0x plus 2. Well, 0 times x is 0. And so we can actually say that our equation is y is equal to 2. So those are pretty straightforward. And this is what you would do with just about any graph. Now, what if we didn't have an easy way of counting it like I did? Well, don't forget your other equation, all right, for slope. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that same equation that we learned so long ago can help you do that. And we could literally do the exact same thing here and plug in. We know that this would be 0, 0, and this would be 1 and 3. Plug those ordered pairs into this equation, and we would have found out that our slope was 3. And we could have done the same thing here, and we would have plugged it in those values, and we'd have found out that our slope is 0. But in this particular case, we can just count it out on our graph. Now, let's look at number 3 and 4. So, what do we want to know? First off, we want to know our slope. Well, that one's the easy one. because all we have to do is look at the difference. So here's my x value. All right, and each time I go up 1 in x, so this will be a +1, this is a +1, and this is a +1. That is the difference between each and every one of those x values. That means that my run along my x-axis is going up 1 each time. So that would be my run. And now we're going to look at our y, which represents our rise and our slope. And notice how it goes up by +2 each time. So that would make our slope to be a rise of +2 and a run of +1. Or we can just simply say that our slope is 2. Now the next piece is b. Well, this might seem difficult at first, but if you look at your table here, it actually tells you what it is. Remember, when you are looking, and I'm going to use this for an example, when you are looking where it crosses the y-axis, this ordered pair happens to be 0, 2. That is the ordered pair for where it crosses the y-axis. Over here, it happened to be 0, 0. And what do you notice in both of these things? Well, the y-axis, when you cross it for the y-intercept, the x will always be 0. And this is a rule. If you want to know what the y-intercept is, you need to know that x is 0. So automatically, if you see this, x is 0, and it tells you what y is, that's your y-intercept. That's it. Now that you know those two things, plug it in. Y is equal to a slope of 2 times x plus 5. I'm done. So same concept over here. 1, I can already tell you that I am going to go, I have a +2 each time. And then on these, I have a -1 each time. So my rise is my y, is going to be going along my y. So my rise is a -1, and my run happens to be 2. And then my y-intercept, I already have it in this graph, or this table. It tells me that my is 0. So since at 0, my y is -2, that means my y-intercept is -2. Now just plug in that information. Y is equal to a negative slope of 1/2 x minus 2. And I am done. All right, let's look at number 5. It says the table shows the distance traveled in y in miles after x hours. Graph the data. Is the domain discrete or continuous? So just so we know, this represents our miles and this represents our hours. All right, so I'm going to kind of put this down here. We have hours and then we have miles, okay, in our graph. So let's kind of plot some things out. This is counting by 2, so I'm going to actually do the same thing here. I'm going to count this by 2s. 2, 4, 6, 8. Matter of fact, no, I'm going to count this by 1 so we can have a wider graph. 1, 2, 3, 4, 5, 6, 7. All right, so my hours are counting by 1s. And now I have this. This is counting by 120 each time. So let's count that by 60s along my y-axis. 60, 120, 180, 240, 300, 360, 420. All right, so I've labeled my graph. Now I'm going to plot the points. I have at 0, 0. Then I have at 2 and 120. Then I have at 4 and 240. And then I have at 6 and 360. So I've plotted my graph. The question that we have to ask ourselves is this domain discrete or continuous? Well, think about it. My domain happens to be hours. Can I drive a vehicle for only 1 hour? Yes, I can. Can I drive it for 2.5 hours? Yes, I can. Can I drive it for 5.5 hours? Yes. And because I can break hours up into smaller increments, this is actually going to be a continuous data, or domain, excuse me. And if we want, we can draw ourselves a straight line. And Mr. Lewis is looking for a ruler, and I do not see one right now. But I can use this to draw my straight line. There we go. I draw off camera there for a second. So basically I have made a continuous line. All right, so because all of the data can go in there. Now, it says write a linear function that relates y to x. So again, I'm looking for y is equal to mx plus b. All right, so what is my slope? Well, that's pretty easy. We can again look at what we have. Notice this. I went up 120, so my rise is 120, and my run is 2. And I went up 120 over 2, up 20 over 2. And again, we can see that also in the table, how my x's changed by 2 each time and how my y's changed by 120. Now that I have that, I can simplify that m is equal to 60. All right. And now my y-intercept is really easy because it's at 0. So my y-intercept happens to be 0. Plug that in. Y is equal to 60, x plus 0, and keep it there. I have made my equation. Now, it's asking for the next piece. What is the distance traveled after 3 hours? Well, this is really simple. We can do it one of two ways. One, we can look at a graph. After 3 hours, I can trace my line from my x-axis of 3 and go all the way to where the line crosses. And then I can trace it back to my y, and that tells me it's 180 miles. So that will work. So that's one method that we can use. However, the best method is actually to use our equation. Y equals 60, and x is going to be 3. Because x represents time, and so x is 3 hours. Plug that in, and we get y is equal to 180 miles. So that's two different methods using the graph and using the equation to solve for that problem. And that's kind of it, guys. There's nothing really more to this. And that's it. You do have a quiz coming up on sections 5.1 through 5.3. And I will, as always, ask me questions if you need to, and I will see you in the next video. Bye-bye.